Okay, we have to prove algebraically that the difference between the squares of any two consecutive integers is equal to the sum of those two integers. Right. Not as difficult as it appears, this question, I promise you. Okay, prove algebraically. We're going to have to introduce our own variable at some point. This is algebra, okay? So how do we do that? The squares of any two consecutive integers. Okay, well, let's start by representing our first integer as x, right? So that can be any integer. Consecutive integers, that means what's the next integer after x? What if x is 27, for example? Okay, well, the next integer after 27 is 28. So the next one after x is x plus 1. Okay, so that's how we represent our two consecutive integers, x and x plus 1. Right. The sum of those two integers, okay. Well, the sum of those two integers, that's just x plus 1, which is 2x plus 1. Okay, so the sum of those two integers, 2x plus 1, we have to show that that's equal to the difference between the squares of these two integers. Right. So what's the difference between the squares of these two? The difference means subtract. Okay? So let's take the bigger of the two, this one, x plus 1, and square it. Okay? That's the square of the larger integer. And the difference between the square of that and the square of that is the square of the larger one minus the square of the smaller one. Okay? So the difference between the squares of any two consecutive integers, right, that bit is that. So we've got to show that that equals that. Then we've won. Okay, so this is an expression. Let's multiply out the brackets and evaluate it, and it should turn out to be 2x plus 1. Let's do that. So to multiply out this bracket, remember, it's not just x squared plus 1 squared. That's bad. You have to write it out in full. It's x plus 1 all squared, which means x plus 1 times x plus 1. Okay? And don't forget the minus x squared there. So that whole thing is equal to that. Right, let's multiply the bracket. X times x is x squared. X times 1 is 1x, or just x. 1 times x is 1x, or just x. 1 times 1 is 1. And then don't forget the minus x squared on the end. Good. So what have we got? We've got x squared minus x squared. They're gone. And what are we just left with? X plus 1. Well, x plus x is 2x plus 1. There we go. We've done it. We've shown that this, which is the difference between the squares of any two consecutive integers, is equal to that, which is the sum of those two integers. Because that and that are the same. I just want to briefly talk about the result we've just proven. We've just shown that the difference between the squares of two consecutive integers is equal to the sum of those integers. It's actually quite an interesting result. Bit of a mouthful, but what does it mean? Okay, let's take two consecutive integers, 2 and 3, okay? It's saying the difference between the squares of those integers, okay, is equal to their sum. Well, the squares of these two, so 2 squared is 4 and 3 squared is 9, okay? The difference between the squares of these integers means 3 squared minus 2 squared, which is 9 minus 4. Put it there instead. Which is, of course, 5. Okay? The difference between the squares of two consecutive integers, that's 5, is equal to the sum of those integers. It works. The sum of those integers, 2 plus 3. It's quite interesting, right? Let's see if it works with different integers. Let's take 4 and 5. Okay? Right? 4 squared is 16. 5 squared is 25. Okay? The difference, 25 minus 16, is 9. So that's the difference between the squares of these two integers. And 4 plus 5 is 9. It works. Clever, eh? One last example. Let's do 9 and 10. Okay, 9 squared is 81. 10 squared is 100. So the difference between their squares is 100 minus 81, which is 19. And 10 plus 9 is 19. It always works. Clever, right? No?